In the middle of the ocean between the islands of Java and Sumatra, there was a small but powerful volcano known as Krakatoa. It sat in the Sunda Strait, part of a chain of islands in what is now Indonesia. At first glance, it didn't seem especially dangerous. It was just one of many volcanic islands in the region, mostly covered in trees, with steep rocky slopes and quiet coastlines. But Krakatoa had a violent past. Old records and local legends told of earlier eruptions long before the 19th century. Some even said entire civilizations may have been affected by Krakatoa's earlier explosions. Scientists later found layers of volcanic rock in the area that hinted at a massive eruption many centuries earlier, possibly one of the largest the world had ever seen. By the 1800s, the volcano had been silent for a long time. People lived on nearby islands and along the coasts of Java and Sumatra without much worry. The waters around the island were busy with trade ships and fishing boats. The land was rich and full of life. Then, in May of the year 1883, the first clear sign appeared that something was changing. Without warning, Krakatoa began to rumble. A column of ash shot into the sky, surprising nearby ships and startling villagers who could see the black cloud from miles away. At the time, it didn't seem too serious. Many believed the volcano was just letting off a bit of pressure. But scientists of the time, including Dutch colonial officials, took notice. Some began to record the strange activity, keeping notes on the ash, the small earthquakes, and the changing color of the sea near the island. Still, no one could have predicted what was coming. What started as a quiet island in the sea was about to become the center of one of the most powerful natural disasters in recorded history. By the middle of August, in the year 1883, Krakatoa was no longer quiet. The warning signs had become impossible to ignore. A thick black cloud hung over the island, and loud booming sounds echoed across the sea. Ships passing through the nearby Sunda Strait reported seeing ash fall onto their decks. Some described the strange sight of lightning flashing from inside the ash cloud, something now known as volcanic lightning. On Sunday, August 26th, the first massive explosion happened just after noon. It was so loud that it was heard more than 1,000 miles away in Perth, Australia, and even farther in places like the island of Rodriguez, over 2,800 miles away. People thought it was the sound of gunfire or cannon blasts, but this was only the beginning. That evening, and into the early morning hours, the volcano erupted again and again, each time with more force. The island was breaking apart from within. Tremors shook the ground and the sky turned completely dark with ash. The sun disappeared behind thick clouds of dust and rock, and it seemed like night had fallen in the middle of the day. Then came the largest explosion of all. On the morning of Monday, August 27th, just before 9 o'clock. The force of this final blast was unlike anything anyone had ever seen. A huge part of Krakatoa, including the entire northern portion of the island, was blown apart. The explosion sent ash and rock more than 20 miles into the sky. The pressure wave from the blast traveled around the entire world 4 times. Nearby islands were devastated. Coastal towns on Java and Sumatra were shaken to their foundations. But the worst part was not the explosion itself. It was what followed, a massive, deadly tsunami. After the final eruption tore Krakatoa apart on the morning of Monday, August 27th, the force of the explosion triggered something just as deadly, a massive tsunami. As the volcano collapsed into the sea, it displaced millions of tons of water, sending waves racing in all directions. The tsunami struck the nearby coastlines of both Java and Sumatra with almost no warning. Entire villages were swallowed up in minutes. In some places, waves reached as high as 120 feet. Fishing boats were thrown far inland. Houses, markets, and mosques were reduced to splinters and carried away by the water. People who had survived the ash and falling debris now found themselves facing an even greater danger, the ocean itself. Some of the most devastating damage occurred in the town of Merak, on the coast of Java. Eyewitnesses described how the sea suddenly pulled back, leaving fish flopping in the sand. Then a towering wall of water appeared on the horizon. Within seconds, it crashed into the town, wiping it off the map. No buildings were left standing. Farther away on the island of Sumatra, the waves still reached with terrifying force. One survivor from a coastal village described climbing a tree to escape the water, only to be thrown back down as the tree was torn from the ground. Entire families disappeared. Those who lived through it often did so by clinging to pieces of wood or floating in the floodwaters for hours. Even ships at sea were affected. Some vessels reported being lifted and thrown by the sudden waves, while others vanished without a trace. reports as far away as Sri Lanka and India recorded strange water movements caused by the tsunami. In the Indian Ocean, the shockwaves continued to ripple outward, eventually being recorded on tide gauges as far as South Africa and even the English Channel. The death toll was staggering. Over 36,000 people lost their lives, most of them from the tsunami. In many coastal areas, there were simply no survivors to tell what happened. The landscape was changed completely, towns erased, harbors reshaped, and the coastline carved anew by the sea. Krakatoa's eruption was over, but the suffering had only just begun. The people who lived through it faced a world that looked nothing like the one they had known the day before. After the eruption and the tsunami, Krakatoa's effects continued to spread far beyond Indonesia. In the weeks and months that followed, people around the world began noticing strange and beautiful changes in the sky. Sunsets turned deep red and orange. Some places reported purple twilights and golden clouds. In cities like London, New York, and Rio de Janeiro, the sky glowed in unusual colors long after the sun had gone down. These changes were caused by the massive amount of volcanic ash and gas that Krakatoa sent into the upper atmosphere. That ash spread across the globe, carried by high winds, sunlight hitting the tiny particles scattered in a different way, causing the strange colors. People did not know at the time that what they were seeing was connected to a volcanic eruption on the other side of the world. In some countries, people thought the red skies were signs of war or a message from God. Artists and writers tried to capture the strange light in paintings and poems. One of the most famous paintings from that time, The Scream by Edvard Munch, is believed to have been inspired by the red sky that followed Krakatoa's eruption. But the ash did more than change the sky. It also affected the weather. The sunlight that reached the Earth's surface was slightly reduced, causing global temperatures to drop. The year after the eruption, many places reported colder weather and strange patterns in rain and snowfall. This cooling effect was felt for more than a year. Scientists at the time were still learning about volcanoes, but Krakatoa helped change that. It was one of the first natural disasters to be studied using worldwide communication. Reports from telegraph offices and weather stations were collected and compared. The event helped scientists understand how volcanic eruptions could affect the whole planet. Krakatoa's eruption also taught a painful lesson about warning systems and preparedness. Many people living near the volcano had no idea of the danger they were in. Afterward, efforts slowly began to improve ways to monitor volcanoes and oceans. Today, that tragic eruption is one of the reasons early warning systems exist for tsunamis and volcanic activity. In the end, the eruption of Krakatoa in the year 1883 was more than just a disaster for Indonesia. It was a global event that shook the earth, changed the sky, and left a deep mark in both science and memory. The volcano itself was mostly destroyed, but its story still lives on as one of the most powerful and far-reaching natural events in human history. In December of 1811, the heart of the American frontier lay quiet under a crisp winter sky, completely unaware of the catastrophic events about to unfold. The epicenter of what would become the New Madrid earthquake sequence was near the small river town of New Madrid in what was then the Louisiana Territory. This settlement was home to roughly 400 people, pioneers, riverboatmen, and Native American tribes, living along the Mississippi River in a world defined by dense forests and wide-open plains. For them, earthquakes were something distant, events that occurred in mountains far away, not the flat, seemingly stable lands of the central United States. Their log cabins and wooden homes were designed to withstand storms, not a ground that would soon roll and tear like liquid beneath their feet. On the night of December 15, 1811, residents described the air as unusually thick, almost oppressive. Families went to sleep as they normally would, unaware that within hours, their world would be violently shaken. The Mississippi River, usually a calm and reliable force, flowed quietly past their homes, hiding the immense power that was gathering beneath the earth. There were no warnings, no seismic instruments, and no prior experiences in this region to hint at the destruction about to strike. Then, in the early hours of December 16th, the first great shock hit. The epicenter lay in present-day northeast Arkansas, but the shaking radiated for hundreds of miles, affecting areas far beyond New Madrid. People described the ground moving in waves, snapping mature trees, and throwing sand and water from fissures that opened across the landscape. Even distant observers reported hearing loud thunder-like noises that seemed to roll across the land. For the inhabitants of the Mississippi Valley, this was an incomprehensible and terrifying event. The Earth itself had come alive, and the frontier would never feel the same again. At approximately 2:15 in the morning on December 16, 1811, the first massive earthquake struck the New Madrid area. Modern estimates place its magnitude between 7.2 and 8.2, making it one of the strongest earthquakes ever recorded in the central United States. Residents described a violent shaking that threw them from their beds, while trees snapped and buildings creaked under the force. Eliza Bryan, a woman living in New Madrid at the time, recalled hearing a deep, vibrating roar, resembling thunder, but far more intense and persistent. Outside, the landscape was in chaos. The ground heaved in visible waves, rising and falling by several feet, and geysers of sand and water erupted from fissures that had opened across the Mississippi River floodplain. Log cabins and chimneys were toppled, and entire groves of trees were uprooted. People screamed in panic, many believing an attack was underway, while livestock fled in terror. The Mississippi River itself appeared to boil and churn, reflecting the upheaval beneath the surface. Just hours later, as dawn broke on the 16th, a powerful aftershock, estimated at magnitude 7.0, struck the same region. The second shock caused further damage to the already weakened structures and intensified the psychological strain on the survivors. Buildings that had survived the first quake now collapsed, and soil liquefaction swallowed parts of farmland, leaving the land unstable and treacherous. The small settlement of Little Prairie, now Caruthersville, Missouri, was almost completely destroyed, forcing residents to flee. In the days that followed, thousands of smaller tremors rattled the region, keeping the population on edge. People avoided indoor spaces, fearing their homes could collapse at any moment. Trees continued to topple, and new cracks opened across the terrain. The Mississippi River's banks shifted, and sand blows, large deposits of water and sand forced from below, scattered across fields, destroying crops and altering the local landscape. The frontier community had entered a state of ongoing terror, unsure when the earth would strike again or if it ever would stop. After the terrifying shocks of December 16, 1811, the region remained on edge. Residents of the Mississippi Valley had barely begun to assess the destruction when the earth struck again. On January 23, 1812, a second major earthquake shook the Missouri boot heel. This tremor, estimated at magnitude 7.0 to 7.8, caused fresh fissures to open in the ground, warped the riverbanks, and triggered landslides along the Mississippi. Though smaller than the first quake, it reignited fear across the sparsely populated settlements. Log cabins that had survived the initial shocks were now badly damaged or destroyed, and new sand blows emerged, further altering farmland and low-lying areas. Then, on February 7, 1812, at approximately 3:45 in the morning, the third and most powerful quake struck. With modern magnitude estimates ranging from 8.7 to 8.8, it obliterated what remained of New Madrid and surrounding areas. The shaking was so intense that it caused the Mississippi River to temporarily flow backward, forming temporary waterfalls and rapids. Ground uplift and subsidence permanently reshaped the landscape, creating the 15,000-acre Reelfoot Lake in what is now Tennessee. Entire forests were submerged, and islands that had stood for decades vanished beneath the water. The destruction was compounded by ongoing aftershocks, which continued for months. Settlers reported that the land heaved beneath their feet even when the major quakes had passed, and thousands of smaller tremors kept the population in fear. For those who had survived the first shocks, the February quake was a terrifying confirmation that the disaster was not over, and that the earth itself had become an unpredictable and dangerous force. Communities were displaced, crops destroyed, and the frontier wilderness now included vast areas of flooded, unstable land. By the end of the series, the New Madrid area had been permanently transformed. While the human death toll remained relatively low due to the region's sparse population, the psychological and environmental impact was profound. Families abandoned towns, farms were ruined, and the Mississippi River, a vital transportation route, was left unpredictable and altered for decades. The earthquakes had proven that even the heart of the continent was vulnerable to immense geological forces, setting a precedent for understanding seismic risk far from tectonic plate boundaries. So why did these earthquakes strike so violently in the middle of the continent? Unlike the West Coast, which sits along the San Andreas and other active plate boundaries, the New Madrid region is far from any major tectonic edge. The answer lies deep beneath the surface in an ancient geological feature known as the Reelfoot Rift. Around 750 million years ago, this part of North America attempted to split apart, forming a continental rift. The attempt failed, leaving behind a buried network of weakened faults, including the New Madrid seismic zone. Over time, tectonic pressure accumulated along these faults, and in 1811, it finally released catastrophically. The region's geology magnified the shaking. The Mississippi Valley is composed of soft, alluvial soils deposited by the river over thousands of years. Unlike bedrock, this loose sediment transmits seismic waves more efficiently, allowing the quakes to be felt across huge distances. In fact, the shaking was recorded over 1 million square miles, reaching as far north as Canada and as far east as the Atlantic coast. Chimneys toppled in Kentucky, homes shook in Ohio, and church bells rang in Boston. The quakes demonstrated that earthquake damage is not solely determined by magnitude, but also by the type of ground beneath communities. The New Madrid sequence also permanently altered the landscape. Sand blows, volcano-like eruptions of water and sand from below, covered vast tracts of farmland, while massive sections of the Mississippi riverbank collapsed. Reelfoot Lake was created when the land sank and the river flooded the depression. Smaller waterways shifted course, and some low-lying forests were permanently submerged. The quakes even caused small river islands to disappear, forever changing the region's geography. Beyond the physical changes, the events offered scientists the first clear insight into intraplate earthquakes, those occurring far from plate boundaries. Observations of soil liquefaction, fissures, and river reversal provided invaluable data for future studies. Today, researchers continue to monitor the New Madrid seismic zone, which averages around 200 small quakes annually, most too minor to be felt. Historical analysis of the 1811 to 1812 sequence informs modern earthquake preparedness, hazard mapping, and building codes for areas that were previously thought safe from major seismic activity. For those living along the Mississippi today, the lessons of the New Madrid earthquakes remain crucial. The dense population, critical infrastructure, and economic significance of cities like Memphis and St. Louis mean that a repeat of the 1811 events could cause far greater human and financial loss than the sparsely populated frontier ever did. Understanding the science behind these quakes is not just historical, it is essential for modern disaster preparedness and risk mitigation. The New Madrid earthquakes left more than just physical scars. They left a profound imprint on the way Americans understood natural disasters. For decades, the region's sparse population and frontier conditions meant that many survivors' stories became folklore rather than formal records. Yet the landscape itself preserves evidence of the quakes even 2 centuries later. Reelfoot Lake, the sunken lands in northeast Arkansas, and countless sand blows across Missouri and Tennessee stand as enduring reminders of nature's power. Geologists continue to study these features to better understand intraplate seismicity and the risks posed by dormant fault zones. Modern scientists consider the New Madrid seismic zone one of the most hazardous regions in the eastern United States. The area has the potential to produce magnitude 6 to 7 earthquakes, and even moderate vents could cause significant damage to today's dense population centers. Cities like Memphis, St. Louis, and Cape Girardeau sit atop the same ancient rift system that unleashed the quakes of 1811 and 1812. Infrastructure built without consideration for such seismic activity would be highly vulnerable, and emergency management plans now take the historical precedent into account when preparing for potential disasters. The historical quakes also fundamentally changed American science and engineering. The unusually wide area of strong shaking challenged early notions of earthquake behavior, showing that destruction could extend far from the epicenter. Observations of liquefaction, river reversals, and landscape deformation informed future hazard mapping and helped scientists recognize that earthquakes could occur far from plate boundaries. These lessons would later influence seismic building codes and disaster preparedness strategies nationwide. For the people of the Mississippi Valley, the psychological legacy was also lasting. Oral histories recount the terror, the constant tremors, and the fear of returning to homes that seemed unstable. Generations grew up aware that the ground beneath them was not as solid as it seemed. This awareness contributed to a cautious culture when settling or building in the affected areas, a form of early risk mitigation long before formal earthquake planning existed. Ultimately, the New Madrid earthquakes are a stark reminder that even the most stable seeming land can harbor hidden dangers. They demonstrate how natural forces can reshape the environment, disrupt lives, and challenge human understanding. 200 years later, the quakes serve as both a historical event and a modern warning. The forces beneath our feet are powerful, unpredictable, and demand respect. Preparing for the unseen threats of today depends on remembering the lessons of 1811 and 1812. Lessons written not only in documents, but in the very landscape of the American heartland. On Wednesday, May 27, 1896, a catastrophic event struck the city of St. Louis, Missouri, and its neighboring East St. Louis, Illinois. This historic tornado, known as the Great Cyclone, would go down in history as one of the deadliest and most destructive tornadoes in the United States. As the day began, the weather seemed calm, with people going about their usual activities. The local weather bureau had predicted thunderstorms, but nothing that would indicate the scale of destruction that was about to unfold. Around noon, ominous clouds began to gather and the barometric pressure started to drop. For many, this was a sign of trouble ahead. However, the day proceeded with little concern from most residents, as the forecasters lacked the technology to predict tornadoes of such magnitude. By mid-afternoon, the skies darkened significantly, causing unease among some citizens who sought shelter at home. At 5 o'clock in the evening, everything changed. Thick, swirling clouds took on a menacing green hue as rain began to pour in heavy droplets. Within moments, the Great Cyclone touched down, carving a path of destruction through the heart of St. Louis. In just 20 minutes, this powerful tornado claimed at least 255 lives, injured over 1,000 others, and left more than 5,000 people homeless. The hardest hit areas included the fashionable Lafayette Square and Compton Heights neighborhoods, as well as the poorer Mill Creek Valley. This tornado would not only change the landscape of St. Louis, but also alter its history. It remains the third deadliest tornado in the United States, forever marking May 27th as a day of unimaginable loss and devastation. As the day of the disaster approached, the atmosphere in St. Louis was charged with tension. On May 27, 1896, meteorologists noted a storm system moving through Illinois and Missouri. While they had predicted thunderstorms, they could not foresee the violent tornado that was about to form. The morning began quietly, but by noon the sky was darkening and the air felt heavy and oppressive. The first signs of trouble appeared when a significant drop in barometric pressure alarmed those who were familiar with such indicators. People began to take shelter as the clouds thickened and turned a foreboding shade of green. In the afternoon, the conditions intensified. Around 5 o'clock, the storm system had built up enough energy to spawn what would become the Great Cyclone. Just before the tornado touched down, 2 supercell thunderstorms were developing nearby, creating the perfect conditions for a tornado to form. One of these supercells unleashed a smaller tornado near Bellflower, Missouri, resulting in the tragic death of one woman. By 6:15 in the evening, another F3 tornado struck a school in Audrain County, killing 3 students and injuring many more. As 5 o'clock approached, the swirling clouds unleashed their fury. The Great Cyclone touched down 6 miles west of Eads Bridge and quickly escalated into a powerful tornado. In a matter of moments, the storm began to carve a path of destruction through the city, leaving residents unprepared for the ferocity of what was to come. With nearly 30 tornadoes reported across the region that day, St. Louis was about to face one of the most catastrophic natural disasters in its history. The afternoon of May 27, 1896, transformed into chaos as the Great Cyclone struck St. Louis. Just after 5 o'clock, the tornado touched down with an unimaginable force. It quickly became evident that this was no ordinary storm. Witnesses described a massive, swirling column of debris that roared through the streets, leveling everything in its path. In just 20 minutes, the tornado wreaked havoc across a wide swath of the city. The powerful winds, estimated to be between 168 and 199 miles per hour, flattened entire neighborhoods. Lafayette Square and Compton Heights, once bustling and vibrant, were reduced to piles of rubble. The Mill Creek Valley, a poorer area, faced devastation as well, suffering extensive damage and loss of life. The tornado cut a 10-mile path of destruction, destroying 311 buildings outright and severely damaging over 7,200 more. Streets became unrecognizable as homes, schools, factories, and parks were swept away. The storm was relentless, leaving a continuous path nearly 1 mile wide of broken structures and downed trees. As the tornado moved into East St. Louis, the devastation continued. Within moments, at least 255 people lost their lives, and over 1,000 others were injured. The city was thrown into a state of shock, with survivors frantically searching for loved ones amidst the chaos. Emergency services struggled to respond as they faced the sheer scale of destruction. Once the tornado passed, the air was filled with dust and debris, and the eerie silence that followed was palpable. What had started as a normal day had turned into a scene of unimaginable tragedy, forever changing the lives of those who experienced it. The impact of the Great Cyclone would be felt for years to come, as the city began to confront the overwhelming aftermath of this catastrophic event. In the wake of the Great Cyclone, the destruction to St. Louis was immense, both in terms of physical damage and human loss. The impact on nature was stark, as trees that had stood for decades were uprooted or snapped like twigs. Parks once filled with life lay in ruins, with Lafayette Park becoming a haunting reminder of the storm's power. The landscape of the city had changed dramatically, with entire blocks reduced to nothing more than splintered wood and twisted metal. The aftermath revealed a heart-wrenching scene. Over 5,000 people found themselves homeless, their lives shattered in an instant. Families searched through the debris for any remnants of their possessions, while makeshift shelters sprang up in parks and community centers to provide some form of refuge. Local volunteers rallied to assist the wounded and homeless, digging through the rubble to rescue trapped individuals. Makeshift hospitals were set up to treat the injured, with doctors and volunteers working tirelessly through the night. As news of the devastation spread, aid began to pour in from neighboring cities and states. Offers of food, clothing, and financial support flooded the area, showcasing the resilience of the human spirit in times of crisis. Many residents who had escaped the destruction joined forces with relief efforts, displaying a strong sense of community in the face of adversity. The rebuilding process began almost immediately, but it was clear that recovery would take time. Debris was cleared from the streets, and plans were drawn up for new buildings that would eventually rise from the ashes of the old. The disaster forced a reassessment of building codes and safety measures in tornado-prone areas. Many lessons were learned, which would influence future urban planning and disaster preparedness. The impact on the psyche of the community was profound. For years, the memory of that day lingered in the minds of residents. It was a constant reminder of the tornado's destructive force and a catalyst for change in how cities prepared for severe weather. As the years passed, the resilience of St. Louis shone through, but the scars of the Great Cyclone remained etched in the city's history. The Great St. Louis Tornado of 1896 left a lasting impact on the city and its people, shaping both its physical landscape and its future. The tornado, which lasted just 20 minutes, destroyed thousands of homes and buildings, leaving over 5,000 people homeless and causing more than $10 million in damage at the time. In today's value, that would be close to $5 billion. But the true cost of the disaster was much more than just monetary. It was felt in the lives lost and the city's collective trauma. In the years that followed, St. Louis rebuilt itself from the ground up. The areas hardest hit, like Lafayette Square and Compton Heights, were eventually restored, though some of the poorer neighborhoods, such as Mill Creek Valley, faced greater challenges in recovery. The rebuilding effort brought about a renewed focus on urban development, with better construction practices and an awareness of the need for storm preparedness. While technology at the time couldn't predict tornadoes accurately, the storm underscored the importance of improving weather forecasting and response systems. The tornado also had a lasting effect on the city's political and social landscape. In the 1897 city elections, reform candidates who had hoped to change the direction of St. Louis were defeated. The political shift was partly influenced by the devastation of the tornado and the role it played in mobilizing communities, particularly those heavily impacted by the storm. As St. Louis recovered, it continued to grow and eventually played host to the World's Fair just 8 years after the disaster, a testament to its resilience and determination to move forward. The tornado remains the third deadliest in United States history, and its legacy is still remembered today. It stands as a reminder of the sheer power of nature and the importance of preparation, community, and perseverance. St. Louis may have been scarred by the events of May 27, 1896, but the city's ability to rebuild, recover, and remember is what truly defines its story. The Great Cyclone will forever be a part of St. Louis's history, a symbol of destruction, survival, and the enduring strength of its people.